Okay, hello. This is assignment 1. This is our fluid simulation for the 3 flows that we're going to be working on today, which are the Poisseuille flow, the Couette flow, and then the hybrid flow, both of them. So we can go ahead and get started. Okay, so we opened up Workbench. We're going to go ahead and open up Fluid flow, Fluent, and then drag this into our project schematic. Let that load. Once it does, we're going to go ahead into geometry, right click it so we can open design modeler and let that go ahead and load. Okay, so it finally loaded. Let's go ahead and continue. So we're going to be working with this 2D shape, so we're going to go ahead and click our XY plane, make sure it's facing us so it's easier. Alrighty, and we're going to go to sketching, and we're going to draw a rectangle. Before we do, we go ahead and change the units to millimeters. Perfect. Then we're going to go ahead and draw the rectangle. We're going to go ahead and draw this out. Let's say that much. Okay. And then we're going to add the dimensions to it. General is already clicked, so we're going to go ahead and click on the edge and drag it out. Try to get it centered. Perfect. And then this one, we're going to drag it out right here. Perfect. Okay. Now in the instructions for the assignment, it said that the length was 50 times the height. So let's go ahead, and V1 is our height right here. So let's say it's 10 millimeters. And let's say our height is 50 times that, which is 500. It's going to be pretty big. So we're going to go ahead and click the little our tool to drag it over. All right. Okay. Perfect. Now we have it centered. All right. So great. So now what we're going to go ahead and do is we're going to go into concept and start choosing the surfaces for our sketch. So we're going to go ahead and click all the lines that the rectangle has. All right. And we're going to go ahead and select apply here. Okay. Seems like all of them are there. And generate. And there we go. We have a surface on our geometric shape. And that should be all for this section. Perfect. So go ahead and we're going to exit out. Great. So now we're going to work on our mesh. Now that geometry is done, let's go ahead and open that. All right. So now our meshing has opened. Let's let it finish loading. Perfect. There is our geometric shape. So again, want it to be facing us. Zoom out on it a little bit. Cool. All right, so we're going to go ahead and start with the mesh. So we're going to right click the mesh and we're going to insert a method. We have to make sure that we want to work with this particular shape. So we're going to go ahead and select this geometric shape. Click apply, and basically there we defined our body that we're going to be working with. Perfect. Now we're going to go again back into mesh, insert, and now we're going to start working on the spacing in the mesh. So let's go to sizing, and we have to do 2 separate ones. We got to do one from the height and one for both of the lengths. So let's go ahead and start with these. Oh, why is it not working? Oh, forgot. We have to click on edges. There you go. Now it'll work. So edges, click control so we can choose our second edge. So now that we have those 2 endpoints, I'm gonna go ahead and click apply. And then we're gonna go down to the type and change it from element size to number division. And I think we can go with 100 here. That should be good enough. Let's go ahead and now click generate. And we should start seeing some mesh and spacing. Alright, great. Still pretty big, so we're going to go ahead and now do the top and bottom. So again, right click on the mesh, insert, sizing. It's on edge, so that one, and then that one. We're going to click apply. Perfect. We have those two edges, and again, we're going to have to change the element size to number division. Number of divisions, let's try 300 and generate. And let's wait for that to process. Okay, I mean, that's not bad. Try 250 instead. I think it really matters, but okay, a little better. I like that a little better. Okay, yeah, much better. Okay, perfect. So now we have our end sizing for our endpoints, and then for the top and bottom. Now the last part to do is the face of the meshing. So we're going to go ahead and do that. We're going to apply the whole thing. We're going to click apply, and we're going to go ahead and click generate. Should basically just fill up the whole shape. Okay, perfect. So if we zoom in, you see those spaces are really small. Awesome, perfect. So this is what we were going for. So we got it right. Great. So one last thing that we do that I found pretty helpful while practicing this was naming my edges. So we're gonna go back to our edge selector. Gonna click on this one, let's say, and then press N, and we are able to name them. So that one's gonna be our inlet. Oh. Okay. And then this one is going to be our outlet. Now these two are going to be our top and bottom wall. So I'm going to go ahead and just call this one top. And then we're going to call this one bottom. Alright, perfect. And that is all as far as the meshing goes. We can go ahead and close this one out. Alright, great. So now that we're back here, you see the little lightning bolt. We gotta go ahead and right click and update our mesh. Alright, cool. So now that's done. So now our mesh has a little check mark, so we're good to go. So now we're gonna go into setup. Okay, so now we're launching our simulator. So we're gonna go ahead and, as far as our options, I'm pretty sure we just have to click double precision, and that is all. So we're going to go ahead and click start. Okay, so now it opened up. I have to, oh, still loading. Okay, so I have to go ahead and make it small, make it bigger. Computer's a little doozy. Okay, great. So we have the mesh. Everything is pretty much settled. So before we start anything out, we have to go into physics, and we're going to choose viscous. There we go. Okay, this is the type of flow that we're going to be working with. All the flows are laminar. So we're going to go ahead and click on that to make sure that that is what we're going to be dealing with. Great. So let's move on to the next section. Now, we're going to go ahead into our fluid section in our materials and click air. Okay, so we're going to be working with the air. So we're going to change the density to 1. And our viscosity, we're going to change it so the Reynolds numbers is small enough. So we're going to go ahead with 0.0004. Yeah, this should be a good number. Okay. Once we're done with that, we're going to close it. Okay. Now we're going to work on our boundary conditions. So let's go into the inlet, and we're going to change this. Okay. So we want to work with this. So the velocity of our inlet, let's say it's going to be 10 meters per second. Let's go ahead and click OK. And as far as adjusting our conditions, that is it. The outlet should just be pressure, and the walls are stationary, so they will not be moving. So we'll go ahead and close those out. We're done editing these. So we're going to go ahead, scroll towards the bottom, and we're going to start initializing our process. We're going to initialize. All right, once it's finished running, I'm going to go ahead and run calculations. Perfect. Okay, so we're going to go ahead and do this. Before we move on, we got to choose the, oh no, this is one. I'm sorry. Our number of iterations are the ones that we change. Best one that works for my computer so far has been 300. It's efficient, so let's go ahead and calculate it. Alright, and it's going to go ahead and start running. So our mesh will be replaced by this graph that we're going to see here. And it's going to slowly iterate, and it's going to create what will be our flow. It will take a couple minutes, so hopefully not too long. Alright, so our calculations are done. We're going to go ahead and click OK. So all the conditions that we did here were for the Poisseuille. So now we're going to go ahead and just minimize it, because we will need to come back to that to edit those numbers for the other flows. So let's go ahead and now click on our results. Alright, great. I think it's done loading. Yes, I think we can go ahead. Okay, make sure our shape is facing us. So here's our symmetric, our little rectangle that we've been working with. So we want to go ahead and make a quick velocity contour. I mean, not quick, might take a second. So let's make our velocity contour. All right. So our location is going to be the shape, which is symmetry 1. Perfect. We're going to go ahead, and our variable is not going to be pressure. Instead, it's going to be the velocity in the u, which is the x direction. So we're going to go ahead and click that. Number of contours, let us try 200. 200. Let's try. Let's try 200. Yeah. it will generate it and it will show us, yeah, there you go. Pretty good. I think I'm looking pretty good. If you look at it, the blue and the blue up here shows the stationary walls and the flow within, which is what we're looking for. All right, so fantastic. So let's go ahead and now we're going to make a chart right here. Before we make the chart, we have to make 2 lines. So we're going to choose the midpoint and the endpoint. So we're going to head into location. I'm going to click on line. We're going to say line 1. All right, so line 1 is going to be our midpoint. So we use 500 millimeters, but this is in meters. I have to remind myself that. So now, instead, we're going to choose the middle section, which is 250 millimeters, so which is 0.0250. 0.2 is going to be the same exact thing. It's going to be the halfway point. Perfect. And then the y is just gonna slide this all over. We could just put also 0.01. All right, and that is all. We're gonna go ahead and click apply. It's gonna go ahead and create that. Perfect. And we're gonna go ahead and create a second line. That second line is going to be our endpoint. So since we did 500 millimeters, we're gonna do 0.5. I believe. Yes. 0.5. And again, this is going to be 0.01. That's all the way at the end. Perfect. Apply. All right. So I think we should be ready to go into our chart. Chart, let's just call it chart 1. It will create the chart for us. Let's say this is for the profiles of velocity. So we're going to just call it the velocity profile. In a pipe, because that's what we're working with. Perfect. It's XY lines. Perfect. So now we're going to edit our data series. Now we're going to create series 1. Let's say series 1. Replace that name with midpoint. Okay, and the location for our midpoint is going to be line 1. Perfect. So now we're going to go ahead here and add a new one. Our series 2, we're going to replace that with endpoint. Could also just call it end, but better for my head to organize. All right, and the location for that is going to be line 2. Great. All right, now let's work on the x-axis of the chart. So our x-axis focuses on the velocity in the x direction. So that's going to be velocity u. We're going to go ahead and click that. And now our y-axis is going to be just our y-axis. It should just be y. Nothing more. And that is all, I believe. So we're going to go ahead and apply. And we should see, perfect, this curved type of graph. That is exactly what a Poisseuille curve looks like. So perfect. All right, so that is our first flow. Let's go ahead and start our second flow. So we're going to go ahead and back into Fluent and edit our numbers now. Now, we're going to go ahead and change a couple things here. So our inlet, we're going to go ahead and change our, oh, what happened there? There we go. Our velocity, let's lower this to 0.5. Yes. This is for our Couette flow, okay. Did not mention that before. Our outer. Pretty sure we have to change the type of it now. Yes. So the type is going to be outflow now, because it is a Couette, and then our wall. Our wall has to change because now they're not stationary. The bottom one is, the top one is not. So we're going to double click on that. And once it loads, there we go. We're able to show that we can move the motion of the wall. So we're going to say it's a moving wall. And let's say the speed of this is just 1 meter per second. Okay. All right. Oh, and before I forget, we also have to change the viscosity here. Make sure our Brinell number is small enough. So I believe we can go now with 0.0005. Let's try this one. All right, so change and create. Perfect. We're gonna go ahead and close it. And now all of our things should be okay as far as our conditions. Now let's go to initialize again. So we will initialize. Once it is done, we will run our calculations. And we gotta change the profile update interval to 0. Once we do that, we can go ahead and calculate. And again, our previous graph will be replaced with the new graph, which will show us the flow for our Couette flow. Should take a little bit. All right, so that took a little longer than I thought, but okay, so calculations complete. Great. So we see here, this is the result that we got from it. So we're going to go ahead and go back to our simulator right here. Oh, and you're going to see, we're going to see this pop up. It says that we have new data. So we're going to go, yes. Gonna go and update that data. Hopefully it comes out right. All right, there we go. So a Couette flow is supposed to be linear. It's going to be linear distributed. So the graph already shows that. So that's perfect. And if we go ahead and we look at it, our flow, it's what we were talking about. This is a stationary wall. This is a moving wall. Perfectly shows that it's pretty linearly distributed, I would say. So great. We're able to see the boundary. That's great. All right. So that is our Couette flow. So we're going to go ahead and do our last one now, which is our hybrid flow. All right. So we're going to go back and edit our numbers here so we can get them. So first, we're going to want to change our inlet. And we're going to change the type of inlet. So we're going to go right click and then we're going to click on type. Once we are at type, we're going to go to pressure inlet. So that's what we're going to want for the conditions for the hybrid. So let's wait for that to load. I'm just going to click OK. All right. And then here for the outlet, we're going to change the type as well to pressure outlet. Don't know why it's coming that little, but yeah, okay. Great. So we fixed that. Our walls are going to stay how they are. we're going to keep the bottom stationary and the top is going to be moving like we said it was, because it's a hybrid between both of them. So that's why we're going to stay the same. And now the last thing we're going to do is, again, one more time, change our viscosity constant, add a 0, make sure our Reynolds number is nice and low. And that should go ahead and do the trick. Go back to initialize, perfect. All right. Okay, perfect. It's done. So we're going to go ahead and run calculations. We're just going to click calculate. And again, the data from this graph right here. That was fast. Did it do it? Let's go ahead and check. So we're going to go back to our simulator. Something's not right. Let's go ahead and do that. The type, pressure inlet, pressure outlet, yeah. Top wall is moving, how we set it. Oh. Let's do that again. Top wall is moving, yeah, okay. And then our air, we said it was that, yeah, close. Let me try one more time. Initialize, current data. Yeah, let's try and initialize again. Maybe I did something wrong here. Okay. Run calculations. 300. Okay, let's calculate. There we go. Now it's working. All right. Must have been a little technical error of mine. So again, it's doing its iterations. The information here is being replaced again. So this should help us get our hybrid flow. All right, so now it's done. Okay, so hopefully we did this right. Okay, we're gonna go ahead and minimize it. Again, it's gonna say new stream, upstream data. All right, I'm gonna click yes. Hopefully it comes up to what we expect it to look like. All right, so let's check it out. I'm gonna go ahead and zoom in on this. And just looking at this kind of makes sense already as it is. So we'll verify with the chart in a second. So again, this bottom wall does not move, this top wall does move, the flow is within it. This makes sense. It looks like it would be a hybrid of both the Poisseuille and the Couette. So let's check our chart to verify that we're doing this right. It's glitchy again, so we're gonna go here, just check on the chart, and yes, this looks like it makes sense. Yes, absolutely. Starts at 0, as it should, and it goes all the way like this and stops right here, which is at 1, which is the velocity of the plate. So there you have it. Here is the hybrid flow of both the Couette and the Poisseuille. So we were able to see all of the flows for them. Since the first one we were able to see the layers within, and we were able to confirm all of them with the chart. All right, thank you for watching.